Welcome back. This is part 2, reviewing reviewing the chapter section 8.2 equations of planes homework. We're just going to complete question 10 and we'll be done. Okay, so let's begin. So 10a. So the question is asking write a vector equation and parametric equations for each plane. So it's always easier to get your vector equation first and then your parametric equations easily follow. So question A contains the point and has direction vectors A and B. Well, this one's quite simple. The equation of a plane, remember, is, I like to write R equals some known point. So the known point here will be 6, -1, 0, plus the direction vectors S, that's multiplied by the parameter, 2, 0, -5, plus T equals 1, -3, 1. So some people will write, instead of R, just X, Y, Z. That's perfectly fine as well. I just like writing R because I'm lazy. But both are fine. And that's the general equation of a plane, right? We have one point, and we need two direction vectors. We scale and multiply them, add them together. That gives us the full equation. So now the parametric, they quite easily follow X, Y, Z. We have 6 plus 2s plus t, 6 plus 2s plus t, -1 plus 0s minus 3t. Z equals 0 plus, minus 5s plus t. And those are parametric equations. Moving on. Let's do question B. Contains the point, P naught, is parallel to this line L1, call it, and this other line L2. Well, line 1 and line 2, they have their own unique direction vectors, which will be this guy and this guy. So we can take those two direction vectors, use them for our equation of the plane, and then use the known point to give the full equation. So R equals 9, 1, -2 plus S equals 1, -1, 1 plus T equals -6, 2, 5. And then X, Y, Z. We have 9 plus S minus 6t, 1 minus S plus 2t, and then minus 2 plus S minus 2 plus S plus 5t. Okay. Another way you can think about why I chose the direction vectors from the lines is because to construct the plane, it's like a two-dimensional object. So I need two directions, in a sense, to talk about how I'm going to move along this plane. So if I mimic those two directions from the direction vectors of the lines, I can use that for my full equation of the plane. If that sounds convoluted, feel free to always come and ask me in person and I can probably provide a better explanation. Always be inquisitive. C contains the points A, B, and C. Okay, so this problem is quite a bit unique. Again, for the equation of a plane, the requirements are 2 direction vectors and 1 point. So I have the ladder, I have the point. I can choose either A, B, or C. That doesn't really matter. It's the 2 direction vectors that are difficult. But I can form 2 direction vectors quite easily from having 3 points. So 3 non-collinear points. So they don't lie along the same line. That's what I'm talking about. Okay. So I just need to form 2 direction vectors from these 3 non-collinear points. So let's form vectors A, B, and AC, I guess. And they don't look like they're scalar multiples, so which is nice. AB, AC. I guess I'll form them separately. So vector AB. Remember, this whole unit's about vectors. So if you're given points, can't really play around with points, right? And we need to form some vectors. So what do we do? B1 minus A1, B2 minus A2, B3 minus A3. It's going to be, I'm only going to write down the formula once. I'm not going to do it again for AC. Just going to go straight to calculating it. Heck, why not? I'll write it down here too. So we have 3 minus 1, 2. 3 minus 1 is 2, minus 9, minus 3, minus 12, and then 7 minus negative 2, which is 9. Okay. C1 minus A1, so that's going to be 4 minus 1, which is 3. Negative 4 minus 3 is negative 7. Negative 2, 5 minus negative 2, 7. Just want to make sure that. 1, 3. Yep. Okay, so what do we do now? Just by quick inspection, look to see if these 2 vectors are not scalar multiples of each other, which, if you look, there's not really any scalar multiple that would make AC equal to AB or vice versa. Okay, so then what do we do? Well, then the problem's easy, actually. Because they're not scalar multiples, now we can just write down the full equation of the plane, which is going to be, I'm going to choose point A as my known point on the plane. 1, 3, negative 2, plus S. We'll take the vector AB first. 2, negative 12, 9, plus T, 3, negative 7, 7. Okay, parametric equations next. X, Y, Z, boom, boom. 1, 3, negative 2, plus 2s, 1 plus 2s, plus 3t, 3 minus 12s, 3 minus 12s, minus 7t, 3 minus 12s, minus 7t, yep, minus 2 plus 9s, minus 2 plus 9s, and plus 7t. Lovely. Okay. Okay. And now part D. So part D is actually not at all different from the other part, the one we just did. It's just the points are now labeled as the intercepts of the plane that we want. So x-intercept, y-intercept, z-intercept. We have an x-intercept of 8. So that would be the point. This point, y and z are 0. Y-intercept, x and z are 0. So we have 0, -3, 0. And for the z-intercept, x and y are 0. So 0, 0, 2. Okay? And I'll call these points A, B, and C. And now I just repeat the same process. So let's form vectors A, B, and AC. So I'm going to subtract the components of the points going in the opposite direction as before. So B1 minus A1, B2 minus A2, B3 minus A3. And same deal here. We have C1 minus A1, C2 minus A2, C3 minus A3. Okay. So what do we have? AB, it's going to be the y-intercept minus the x-intercept. 0 minus 8, -8, -3, and 0. AC, 0 minus 8, -8 again. 0 minus 0. And then 2 minus 0, it's just 2. Okay. And then we'll form the vector equation. Let's choose the x-intercept as our known point 8, 0, 0, plus s, -8, -3, 0. A, B, and AC are not scalar multiples of each other. I don't have to be afraid of that. So I can form the full equation of the plane, -8, 0, 2, and just enough room to write down the parametrics. We got 8 plus, or 8 minus 8s. 8 minus 8s minus 8t. Okay. And then we have what other one? 0 minus 3s minus 3s plus t is going to be 0. And then z is going to be 0 plus 0s plus 2t. Just lost my train of thought there with all these zeros floating around. Perfect. That concludes a review of section 8.2 chapter homework. I'll see you soon to go over chapter section 8.3 properties of planes. Thanks, guys. Have a good day.